All right, okay, so we just spent that time before the morning tea talking about how to build a Bayesian network, so now we're going to talk a bit about how to use the Bayesian network, and then we go into actually using it in Netiquette and playing around with this network stuff. So this next section here is reasoning with Bayesian networks. So we've got some terminology here. We're talking about this. So the idea of these probabilistic inference systems is that we want to calculate a posterior probability over some set of query variables. So in our previous example, that was our native fish population and tree condition, about given some evidence variables, which might be pesticide use and drought condition or whatever. Yep. So this is what we call conditioning or belief updating or inference, and that's what we do with Bayesian network. Okay, so we've got a few different types of reasoning that we can do with a Bayesian network. So the first one is predictive, where we have some knowledge about the causes, and we want to make some inference about the effects of that causes. So we know what's happening with the pesticide use, and we know what's happening with the drought condition, and we make an inference about what's happening with the native fish population. We can also use it diagnostically, so reasoning backwards up the causal chain. So we know something about the native fish population, and we want to understand about what's happening with the causes of that native fish population. So that tells us something about what the rainfall situation is or the drought condition. And we've got some other kind of interesting, cool ones, like intercausal. So given that I know some effect, I can make some reasoning inference about what's happening between the different causes of that effect. And we can also use any combination of these types of things as well. So for an example, which I think we come back to a couple of times, was this cancer network. I'll just quickly read it out. Basically, we have some patient that's come into our clinic for a cancer clinic, and we want to know whether or not they've actually got cancer, make some inference about that. Now we know about some of the causes of cancer, such as coming from a highly polluted environment or being a smoker. And we know about some of the symptoms of being a cancer, which might be a positive X-ray result or a shortness of breath, dyspnea. So try to picture how this Bayesian network might look in your head, and I'll show it to you. So we have our cancer here, and we've got the causes of cancer, pollution and smoker, and we've got the effects of cancer as well. Now this thing here, this X-ray to cancer type thing, might not be obvious to you immediately, but we'll play around with that a bit in the future as well. But basically, the outcome of an X-ray result is going to be dependent on whether or not there's cancer. It's a bit different than the way that we often will think about it, because we'll use X-ray to actually tell us about cancer. So often a common mistake that people will make is actually putting this arc around the wrong way. But that's a causal direction there. So we have some rather ugly graphic here about these different types of reasoning. So we've got, in this case here, we're using a diagnostic. So we've found out that our patient has a shortness of breath, there's dyspnea, and we're using that to find out about whether they've got cancer or whether they come from a polluted environment here. We've got our predictive. We've asked them and found out they're a smoker, and we can use that to infer about things down the causal chain. So we can we change our belief on whether they've got cancer, and that will also change our beliefs on whether they're going to get a positive X-ray result or whether they've got shortness of breath. We've got the intercausal here. So in this case, I know that they've got cancer here, and then I find out that that they're a smoker. That will actually tell me something about whether they come from a polluted environment, right? So if I know somebody's got cancer and I find out they're not a smoker, then my belief that they come from a polluted environment will go up, because it explains the cancer, and vice versa. So we call that kind of explaining away. And then we've got combinations here, which is pretty much how the doctor would actually use it. So they might ask some questions first and find out they're a smoker, and then find out they've got a shortness of breath. And we're using both a predictive and diagnostic reasoning going on in there. So we've got all these different combinations of stuff going on here. Now, when we're doing all this, doing this with paper, like we did with the steroid example type stuff, the mathematics would get really complicated. So that's why we built our Bayesian network to do all this for us. So we'll play with Netiquette. So we introduced Netiquette. So I'm just going to go and talk through some of this stuff here. Did everybody get the USB package, or is it still going around, or? Everybody's a bit slow, is it? How many people have got the package on their machine?
3.
We got 3? So a few people? Who doesn't have it, sorry?
No, yeah.
You've got it? Who doesn't have it? You don't?
I don't have it.
You just don't have it. Okay, that's cool. Well, I've got a bit of time before we're going to use it.
So my question was, have you sent it around just recently?
Stephen was the one who passed it around. I didn't.
Oh, okay.
Can I download that off the net?
I'm not certain if we're Stephen's.
Okay, because then I'll maybe just
Yeah, yeah.
You're talking about Netiquette?
Netiquette and the folder stuff. Well, no, actually, we've got a folder of exercises and stuff like that. So there's a USB that Stephen passed around, and I think we sent out an email. I presume we sent out an email a couple of days ago to get people to put Netiquette on their machines, but I'm guessing not everybody's done that. But we will sort that out. Not everybody got a laptop. Anyway, we'll sort it out. Netiquette is really easy to install. One of the reasons why we use it for the training exercises is because it's not too much of a pain. It doesn't mess around with your registry or anything like that.
I made a zip that people should copy instead of the folder, because the folder has like 5,000 files in it or 4,000 files, and that's probably what's taking all the time.
Oh, okay, all right, yeah. Right. Well, we'll just make do for now. So, okay, but I'm just gonna show you some slides about Netiquette, and maybe I'll quickly show you a demonstration on my machine if my microphone leash will let me get over there. Okay, so reasoning in Netiquette. So first thing we do with most programs is we can load up a Bayesian network here. I'll just demonstrate this later on, but we have like a folder here with a whole load of different versions of the native fish, which we incrementally build and we'll show you or get you to build yourself through exercises over the day. So we start off with this native fish version 1, which is the one that I've shown you beforehand. I showed you one I don't think I showed you one with actually the belief bars and the states visible here. We just had those kind of rounded label boxes. We can switch around in Netiquette between those different views here, but this one here you can see that we've got these states that we've decided for each of these variables here, and we've got a belief. This is our initial starting beliefs for each of these different states here. There's this style thing here to switch in between label boxes, which is what we saw beforehand, and the belief bars. Now, one of the main things we do with these Bayesian networks is actually enter in observations, so evidence. The way that you can do that is you can click on a state of a node and it will select that. So if I want to say I've observed that the pesticide use is high, I select that and the Bayesian network will set that evidence in there and then update the beliefs in the rest of the network. So there's a couple of ways we can do that. We can left click on a state, or we can right click and we go through this menu type thing here. So there's a few different ways to do everything within Netiquette. You'll just work it out and find out what works best for you there. Once we can enter in these evidence, then we've got these different demonstrations of different types of reasoning that we can do. So in this case here, I want to do a diagnostic reasoning. So I might do have some observations about the tree conditions. I can see at a particular site that all the trees are dead and that the native fish abundance is low. This is doing the reasoning up there, and my beliefs in pesticide use and drought condition have changed from the original. So what I had at the start was, so drought conditions, before I know anything, I've said that there's a 25% chance of a drought conditions. Now that I know that the situation is pretty dire, so the trees are dead and the fish abundance is low, my probability of drought conditions has gone up a lot. Because that seems to be the best explanation for why the situation is so dire at this site. So we're using our diagnostic reasoning upwards from the causal direction. We've got a predictive reasoning where we might do some observations about annual rainfall, drought conditions and pesticide use. In this case, we're in bad land again. So we've got a really bad situation, so our native fish abundance is, well, it's fairly even across all the different states. And then we've got mixed reasoning here. So we've got high pesticide use, no drought conditions above average rainfall. So this is mixed, isn't it? And we get these in between sort of observations about that stuff here.
So
Now,
do you typically draw conclusions about, so can we just go to the earlier slide?
which one? This one or?
Yeah. So the pesticide use is high, but the drought condition, there is no drought and the annual rainfall is good.
Yeah.
And therefore, you have high pesticide in river.
Yeah.
There's good river flow and there's good tree condition, and therefore you have, so you're trying also, when you look at the final report as a user, let's say,
Yeah.
So I would also try to draw inferences about, okay, the good river flow and good tree condition is offsetting the pesticide effect, and therefore you have, so do you have reports coming out?
Well, there's nothing that's generated by the tools. I don't think any of the tools generate auto reports in that type of way. But yeah, you're just left up to your interpretations. And generally, depending on how you design the Bayesian network, the purpose you build it for, you'll do that type of stuff. But in this type of situation, I know, doing these contrived type ones, so the explaining away one might be a bit of an interesting one. So I know that the native fish abundance is high, and then I find out something about the tree condition, the drought conditions. So native fish abundance is high, find out that there's also a drought here. That's going to change my beliefs about annual rainfall and pesticide use. So my pesticide use has gone down, I think, because they're doing well in spite of the drought. So there must be something good going in the other things. And annual rainfall should be jumping up quite a bit to above average there. So even though it's dry, the rainfall is very much making up for it in this particular year, and that the fish are going well in that type of situation. So it's how you interpret that. But depending on how you design the Bayesian network and what you built it for, that's how you just decide on how you're interpreting and reading the Bayesian network. But none of the tools, apart from just spitting out numbers, they don't really do anything as of yet. Although your tools will, I think, give interpretations. Yes. but we have to be quite specific about what the purpose of the Bayesian network is to really do anything that's meaningful in that sense. Anyway, so we've got the explaining away one there as well, and we've got the mixed one. Now, this is kind of heavily mathematical stuff. I don't know if this is going to be really particularly applicable for you guys, but what's actually happening behind in the Bayesian network is this exact inference. So we've got this application of the Bayes rule here, and what we do is we actually do a message passing algorithm. So if we find out some evidence about C here, that will send up messages to all its neighbours here. So C is going to update our belief about the causes of C, so A and B. It's also going to update our beliefs about the children, so D and E. And then E has children of its own as well. So that's going to go down that way. And D, we can potentially have information going back up this way. So we have this kind of application of Bayes' theorem to sort of update these beliefs for all these different nodes. And we do that kind of like as each time we get evidence, we update all the beliefs. And then we incrementally keep on adding evidence to this. This works when we have like a tree structure which doesn't have loops within it. When we have loops, we start having messages kind of colliding with each other. So what the tools do, Netiquette included, and I think a Generisk as well, is it will turn things into a junction tree. So when we've got this kind of, we've got this kind of loop here, we've got two pathways between B and H here, it will turn that into a tree structure there. This is kind of complicated. If you're all in, some of your programmers might, you'll have different sort of understandings about this stuff, but it's using clicks and different junction trees and stuff like that. But we can represent this same Bayesian network as this tree here. Now, why this is important is when we're doing our Bayesian network, we build our Bayesian network, we do our variables, links, and conditional probability tables, and then we do a compile action, which takes anything that's like a loop, graph type structure like this, and turns it into a tree. Most of the time, that's all good, but if you've got a really dense and complicated Bayesian network, this can be really, really large and really, really slow. So if Netiquette starts saying that it's needing like terabytes of memory to create your Bayesian network, it's probably because you've got an overly dense Bayesian network. But mostly this is just about clicking that a little lightning bolt on the tool, which I'll get Stephen to demonstrate. So this is the lightning bolt here. Stephen, do you want to? So just quickly go through that, that stuff that we just went through. So I opened up native fish already. It's pretty much this normal Windows stuff here. You've got the little folder thingy up in the top corner of the file menu, and you navigate to wherever your folder is. So I think you guys all know how to open files, yes? And then we open up our thing here. So first thing we had like changing the view of the Bayesian network from belief bars to labeled boxes.
Okay.
Star. Yep. Nope. I think select all the nodes. So we can change the view here, and this might be useful when we're presenting our Bayesian networks to experts and we don't want them to see all that extra information there. So we can kind of see the causal structure here a lot easier without distraction. But generally when we're using this, we want this belief bar view. Stephen, we want the belief bar view back. And then we had, do you want to just uncompile it? Kill the compilation? The best way is to take an arc and delete it and undo it. Right, so when you've created your Bayesian network, what you'll first see is these kind of grayed out bars here. It's grayed out because this is not compiled. It hasn't got to that kind of junction tree structure that we wanted beforehand. So the first thing we need to do before we use it is compile it. And in Netiquette and in most of the tools, does the GeneRisk have the lightning bolt as well? It seems to be a very common way to do it.
It has a calculate function, so it's the equivalent of compile almost.
Right, okay. So you see this little lightning bolt up where Stephen's going to do the cursor up to? We click that thing there and that will compile the network. And then it's live. So we can start putting in evidence and it will update fast. So we'll do a couple of demonstrations of the different types of inference. So Stephen will do a predictive inference there where we might say make an observation about drought conditions and see how that changes fish abundance. So you can see as drought conditions changing, fish abundance is changing there. Do a diagnostic one where fish abundance changes things up in the root nodes. An intercausal between, so no, that's a bit more complicated. I would say a tree condition, annual rainfall. So dead and then make annual rainfall, and that's going to make some difference with the drought conditions there. So we've got the two different causes of tree condition. And then we can just put in evidence wherever we want around the network as well. And Netiquette is smart enough to do it all for us and handle it all and makes it all really easy. I think that's all we really need to know. So Stephen's left clicking on the state names to actually enter evidence for a state. So he's saying tree condition is dead. The other way that we can do it is by left clicking and going to the drop down menu. So, and we can do enter finding there, and we can change it to good or damaged or whatever. Now, so what we're going to do is we're going to cut to some exercises. Now, it steps through some of the things about creating it. I'll just quickly run you through actually modifying the Bayesian network as well. So if I want to change the, say, states for tree condition, I can open up the node property box by double-clicking it. And do you want to do the, go from the description to states down there? So I can change the states names here and add and remove them there. And there's a few different types of ways we can do that, and you'll have a play around with that in the tool and you'll work it out for yourself. And then we can do the table. So we go to the table box, table button on the side there, and that'll pull up the conditional probability table there as well. So this is where we'll enter in our numbers in there. Okay, so going back to the end of your book after the, that exercise that we did earlier this morning, we've got, do you want to go to the slides? I think it's like 3 different exercises. Yep, awesome. Okay, so when we're entering in evidence in that last exercise and through the demonstration beforehand, what we're doing is what we call positive specific evidence. So we're going out, what we might be doing is we're going out into the world and we're looking at the river flow or the annual rainfall, and we're taking a measurement and we're going, I know that the annual rainfall is above average. So then we set above our annual rainfall as above average. Netiquette lets us do a couple of other different types of evidence as well. So we also have negative evidence, which was we might go out there and observe that we know that it's not in this particular state. So in Netiquette, you can do that by shift clicking a state. And if you do that, you'll see that it actually, so if we go for annual rainfall and we know that it's not average, so shift left click on a state, and it'll spread the probability mass onto the other 2 states there, and it maintains the distribution weighting. So we've got positive, I know it's in this state. Negative, I know it's not in this state. And there's another one which is likelihood evidence. So this one you have to be really careful about. Some of the tools make it a bit too easy to do this type of evidence, but it takes a little bit more to understand it. But I'll give you a quick sort of understanding about that. So what we can actually do, if our evidence is a little bit noisy, so I actually went out there and I looked and I did like some catching of fish in the river and I got some observation about what the fish abundance is. But that's not 100% reliable. I might have just been in a really good patch where a lot of the fish just happened to be concentrated or something or whatever. So even though I counted that there was a high fish abundance there, might not be 100% certain of that evidence there. So this is where likelihood evidence is. And this other example here is that, the pesticide concentration in the river, they did like 10 different tests of pesticide concentration and 8 of them came back high and 1 of them came back low. So we have this kind of uncertainty about our evidence stuff here. This is where we have likelihood evidence. So when we right-clicked on a node and did the enter finding, I think people mostly just left-clicking on the states, but there's different types of options here for that. So we also have this likelihood evidence here. So the situation with the pesticide concentration is high, and there's different ways that we could do this, right? A way that we could actually explicitly model this situation is by putting an observation in there for that testing type situation. So I can put this observation in here on the pesticide in the river, and when they're saying high, the chance that it's actually high, given that they say it is 80% here. The chance that it's going to be low when they say high is going to be 1 minus the 80%, or 100 minus 80. And again, with low, we have some other type of false positive, negative accuracy there. So if we were to explicitly model it, we'd do it that way. Netiquette, we can do it also by right-clicking and putting in this likelihood evidence. So we're giving these 2 different things here. So the probability that they observe this thing, given pesticide in the river, is high, and the probability that we get this observation, given that pesticide in the river, is low. Now, this is all a bit kind of tricky, and it takes a little while to fully absorb what's going on here. The really short story is that you need to be careful when you're doing this likelihood evidence. But I also think this is a good sort of example to sort of quickly sort of show you what happens with that steroid example when we do it in a Bayesian network. So Stephen's going to fire up Netiquette and do the steroid thing for us, and we're going to try to remember the numbers here. So what were our variables for the cancer network, the cancer problem that we had at the start? Remember, we had the cancer and we had the false positive, the positive test and stuff like that. Anybody want to hazard what the variables are for that?
Smoking, pollution.
No, the one before that. This is the early one. The one where we just had whether or not they actually had cancer, and we had a test result there. So Stephen, we're just going to create 2 variables there for cancer and for our test result. So there's 2 states for cancer. We either have it or we don't, so yes or no, true or false or whatever. And we've got our test result. And we've got 2 possible states for that, which is either they get a positive or a negative result. So we've got our 2 variables there. Now these 2 are related. So we want to put an arrow between this. Does anybody want to hazard a guess on which way this arrow should go? Downwards. So cancer goes into test result here. Now I'll just point out here that some of you might have, but you didn't actually say it, that you might have thought that it should go the other way, although Stephen laying it out like that was a bit of a giveaway as well. But often people, when we ask them about this, is they'll think the causal, they'll tend to think the causal direction's the other way. So they'll go, the test result is informing me about cancer. So I think that the test result is, well, what I end up saying is that a test result is causing cancer, which is not the case.
Yeah, I feel they're the same thing.
No, the causal direction is the test result is caused by the cancer. It doesn't make sense to say that the test result is causing the cancer. It could be, but in this case it's not.
Statistically, they're the same.
Yeah. Yeah. So in this case, we want to be careful about having this test result here. Now we can put in our numbers there. So we've got the numbers up here. Oh no, those are steroids, whatever. Actually, change cancer to steroids. We're in a different world. All right. Okay, so first of all, we had our prior for steroids. So we go to our table for steroid use. And for the first part of that question, what was our prior for steroid? Anybody remember? It was like 1 in 100, I think. 1%. Yeah. So we put that into this table here. So yes, probability of a yes is going to be 0.01. Or if it's a percentage probability, it's going to be 1. And the chance of it being no is going to be 99%. Awesome, done, closed. Test result. And we go to the table for this one here. And this is where we have our false positive and false negatives and all that stuff here. So our first thing was our true positive rate was 95%. So our true positive rate is going to be, we have a positive test result and we actually had steroid use. So this number here is going to be 95. Which means that this number here is going to be 5. Yeah, awesome. And a chance for no, so our false positive rate was 2%. So we have a positive result and steroid use is no, we have 2% here, and we have for our true negative is 98. 98. Okay, we go okay. And then we compile our network.